This is lesson 5 for AP Calculus, which is a lesson on reviewing exponential and logarithmic functions that we studied the previous year in pre-calculus and also in Algebra 2. So this is just kind of a review of these two different types of functions. And so first of all, let's talk about the exponential function. We're talking about the parent function, so it hasn't got any transformations happening to it. And so we say the output, the y, is equal to some base. Now this represents a constant. B is not a variable, it is a constant, some number that will be given in the problem, or you'll be given data to figure out your base, but that will be a constant number. And then the variable is the x, the exponent. So what varies in this function is the exponent, hence it is called an exponential function. If we were going to graph an exponential function, and by the base must be positive. For exponential functions, we're always talking about a positive base, and as well as the base is never 1, because 1 to any power, well, that's just boring. It doesn't have an exponential pattern to it. It's just 1 all times. When we talk about graphing an exponential function, the easiest thing to do is to graph just these 3 points. Again, we're talking about the parent function without any transformations. We pick the inputs of -1 and 0 because you're looking here, you're going to have b to the -1. Well, that would just be the reciprocal of the base. B to the 0 would be 1, meaning any base to the 0 power is 1. And then if you raise the base to the power of 1, to the exponent, to the first power, then we end up with the value of the base. So that's why we have these. And if you just graph these points, we're going to graph it here and make a little sketch in our notes. And we have something like this. I didn't put any numbers here, but they're counting by ones. And this would be a parent function where the base is 2. And we're going to do a second one over here. And we're going to have another, first we're going to talk about, a second one here. And this one is base e. So it's y equals e to the x. And you'll notice they look very, very similar. The difference is when we went to -1 right here, I'm going up the reciprocal of e. When I go to +1, I'm going all the way up to e. And you might say, well, I don't know where e is if I'm counting by ones. And so we should all know that just like we kind of memorized that pi is 3.14159, we really should kind of have it memorized that E is approximately 2.718. And so when we go over 1 unit, we're going to go up 2.718, which is, I kind of just eyeballed it here on this problem. All right. Exponential functions, because it's some positive base to an exponent, is always going to return a positive value. The outputs will always be positive. If I was saying the outputs are always going to be positive, then that means that our range is always going to be positive. It's always greater than 0. Okay. Logarithmic functions are inverses of exponential functions. Okay. So when we see y equals log base b of x, this logarithmic problem, we're saying that the base is b, the y is the exponent, and x is the value, what it equals. So in this case, what is the input for logarithm would be the output for exponential, okay? And what is the output for logarithmic is the input or the exponent for exponential. When I see log base 2 of 8 equals 3, I'm saying the base is 2, the exponent is 3, and 8 is the value. So 2 to the third is equal to 8. Okay. This would be a logarithmic graph. Now, why do I know that? Because we're looking at the fact that an inverse is where we switch our x and our y. For exponential, remember the outputs were 1 over the base, 1, and the base. This time we're going to use those for the input. So here, my input, I would put in here 1 over 2. So log base 2 of the reciprocal of 2. Well, that's going to equal -1. Because 2 to the -1 would be 1/2. And 1, when I have the input of 1, I'm saying log base 2 of 1. 2 to the what power equals 1? Well, 2 to the 0 power. And then here I'm plugging in the base, so I'm going to plug in 2. So 2 to the what power equals 2? Well, that would be 1. And now you can see the table and say, oh, for this particular problem, I'm going to go over to 1/2 and down to -1. Then I'm going to go over to 1 and put a 0. Then I'm going to go over the base, since my base is 2, I'm going 1, 2, and up to 1. And then connect those 3 points, and you have your logarithmic graph. What's important to note here is we have an asymptote, and that is the line x equals 0. When we look back at the exponential graph here, well, we didn't discuss it, but there is an asymptote here, which is y equals 0. This is the line y equals 0. And if the asymptote for exponential is y equals 0, well, then the asymptote for logarithm is x equals 0, because they're reciprocals of each other. The domain, meaning what x values, you can see from the graph, you've always got anything greater than 0. So my domain is greater than 0. Again, for exponential, it was my range that was greater than 0. Now it's my domain is greater than 0, because again, reciprocals, you switch your x and your y. Here we have the natural log of x. The natural log, that's ln, is the natural log of x, and that means log base e of x. We don't typically write this. We don't write log base e of x. We just say the natural log of x, or a lot of times it is kind of slang, but we just say ln of x. But we should really be saying the natural log of x, which means log base b of x. So again, we follow this same rule. It's just that we're going to go 1 over e and down -1. Go over, excuse me, go over 1 unit on the x and stay right at 0, and then go over b units, or in this case, since it's natural log, we would go over e, 2.718, and up 1. So that's what we did here. All right. Remember how we read this? If I wrote log base 10 of 1 equals 0, what we're thinking, because we don't think logarithmically, we think exponentially. We think base 10 to the 0 power equals 1. So log base 10 of 1 equals 0. This is because 10 to the 0 equals 1. Now, I want you to think about the fact that I could have put any base here. Log base any base of 1 will always equal 0, because b to the 0 will always equal 1. Which brings us to properties. Now, we've learned these properties in both Algebra 2 and Pre-Calc. We need to have these memorized, really know them well, because we need to recall this information when we're doing much more challenging problems, which is why we're doing all this review of Algebra 2 and Pre-Calc, because we have to have it kind of in the front of our memory so that as we reach difficult calculus problems, we can just pull from our knowledge of properties of different functions. So we're going to talk about properties of logarithms. And if you need to, make flashcards. So here I have a log of a product. So log base b of a product. We can break that apart. When you are multiplying the argument, we can split that up into 2 logarithms, same base, where we're adding. So log base b of x plus log base b of y. instead of the product in the argument. Here we're dividing our argument. We have a quotient. We have x divided by y. All right? Base b, we can break this up into subtraction. Log base b of x minus log base b of y. And here we have an exponent in the argument. Well, we can take that exponent and bring it out in front, and then we have n times log base b of x. These rules are based in exponential. When you're multiplying like bases, when you're multiplying these x times y like bases, you add their exponents. And remember, log base b of x, this means exponent, because you're going to find the exponents. So when you're multiplying like bases, you add the exponents. When you're dividing like bases, you subtract the exponents. When you have a power to a power, you multiply your exponents. So these logarithmic rules relate to our exponential rules. Now we have two other categories, and we have this one where it says log base b of 1 equals 0. Any base, so log of any base here of 1, meaning when the value is 1, the exponent had to be 0. I can write it this way also, but this is just when the base is e. But we write ln of 1 equals 0. These are related. They're the same property, really. We have in one other property, and that is when the base and the value are the same, then it equals 1, because b to the first power equals b. And we could do the same thing here. ln of e equals 1, because this just means log base e of e equals 1. So those are two, it really is only two more properties that we're putting with there. So now that we've had this little bit of review, I have a do nows that I want you to do these do nows, and I want you to post the do nows to a Google Classroom. So here's the first two. I want you to rewrite without exponents, meaning I want you to simplify. So here I've written two problems with fractional exponents. I want you to review, and if you need to, you could research it online, but how you do these and what they mean, and then we're going to talk about them in class the next day. Okay? And so pause the video, write these ones down. There's 3 more do nows to do. Okay? And here are the other 3. I want you to solve this exponential equation. I want you to evaluate that logarithmic expression. And I want you to expand. This is using the properties of logarithms. Problem number 4. So pause the video, write these down, do them and post them to Google Classroom, and then we're going to talk about them in class tomorrow.